morning, dear students, learners. Today we are going to have second part of the chapter Regression Analysis. We know that regression is the statistical technique in which we predict the value of dependent variable given the value of independent variable. On the basis of this meaning, economists, statisticians, they try to explain two types of regression lines. One is x on y and second is y on x. So far as regression line of x on y is concerned, we can explain it here with the help of this figure, as it is clear that line is y is equal to a plus bx, and this is a is intercept. It is the value of variable y when x is 0. Secondly, what is b? B is the slope of this line. It is the slope of line AC, you can say. This is the triangle ABC. The slope of AC, if we want to have, that is vertical over base, that is CB divided by AB. So this AC, slope of AC is B, that is regression coefficient. Similarly, we can drive another line that is called line of x on y. So this is variable x, this is variable y, and this will be the line of x on y. Here, point to be noted is that x is equal to a plus by. That is, x is dependent and y is independent. A is intercept. This is the value of intercept. So far as the line slope is concerned, that is represented by b. Here b is regression coefficient. We can say that if there is change in y, x will change. So this is called regression coefficient of b x y. This regression coefficient is b y x. So there are two regression coefficients from these two lines of regression. Now, point to remember is that the relationship between regression and correlation can be shown with the help of these regression lines. Now, let us take some points. For example, if this is the line of x on y and the same is line of y on x, it means both lines, they have coincide with each other. In this case, we say correlation is perfect positive, that is 1. If these lines, they are not coinciding, for example, this is y on x and this is x on y, it shows that lines are not coinciding but they are near to each other. Here correlation is very high, so high correlation, high positive correlation. Similarly, if lines they are like this is y on x and this is x on y, that is, lines are at distance. In this case, correlation is low, so there is low correlation. And another case can be when these two lines, they intersect each other at right angle. For example, this is y on x and this is x on y. So this is right angle intersection of these two regression lines. In this case, correlation is 0. So this is the relationship between regression lines and correlation. The next point which we have to concentrate, that is, if these two regression lines, they can give us the value of correlation, how we drive it? We drive it basically with the help of the relationship of two regression coefficients in terms of correlation coefficient. We know that if we get the product of the two regression coefficients and get its root, we get correlation coefficient. We can plot it in this way, as some practicals they will be mentioned in this case. Let us take one example. For example, byx and bxy, if we multiply these two coefficients and get its root, we will get what is called correlation. Why and how? Let us prove it. The byx is nothing but correlation into standard deviation y over standard deviation x. Similarly, this bxy is a correlation into standard deviation y over standard deviation x. If you cancel these terms, that is, these two terms are cancelled out, then we get, this is standard deviation of y or standard deviation x, this is standard deviation x over standard deviation y. So standard deviation y can be cancelled out with standard deviation of y, and similarly standard deviation of x can be cancelled out with the standard deviation of x. We get correlation, its square under root, that is correlation coefficient. So given two variables, two regression coefficients, we can get correlation coefficient. Point to be noted is that both regression coefficients should have same sign. They both should be either positive or negative. Whatever the sign they have, the correlation will have also the same sign. So all the three, correlation coefficient, regression coefficient of x on y, and regression coefficient of y on x, they should have same sign. Another point is, if a correlation coefficient has two limits, that is plus minus 1, regression coefficients, they have no such like limits. Any of the two regression coefficients may be more than 1, but another will be less than 1. Both of them cannot be greater than 1, both of them can be less than 1. The point, next point is that these regression coefficients, they give us the value which is very, very important in research methodology in any of the research projects. Point to remember is that how we calculate these regression coefficients. So I would mention here basically 2 points. One is direct method called least square method, and another is a shortcut method. So if this is the line, that is y is equal to a plus bx, this is our linear equation. From this we get one regression equation, that is y minus y bar is equal to byx into x minus x bar. So these two are mean values of two variables. Byx is regression coefficient. It shows dependence of y on x. X is independent and y is dependent. With the help of least square method, we calculate it in this way, that is sigma x minus x bar into y minus y bar divided by sigma x minus x bar, its square. You know, these are actual values of x and y. If we get its deviation values, we denote it like this, sigma xy over sigma small x square. So this is the way to calculate regression coefficient. Another way is to calculate it in this way, correlation into standard deviation of y divided by standard deviation of x. So you can calculate regression coefficient through any of these methods. Another method is, again, with the help of shortcut method, we can derive this value in terms of assumed mean. So byx will be equal to n sigma dx dy. Dx is deviation of x from assumed mean. Similarly, dy deviation of y from assumed mean. We get their product and then summation. Sigma dx into sigma dy divided by n sigma dx square minus sigma dx its whole square. So these are the methods which we use to calculate b by x. Another is bxy. This is another equation, that is x is equal to a plus by. Here x is dependent and y is independent. If you want to calculate this b, that is, it will be called bxy, not byx. It is byx, bxy. Then numerator will not change, but denominator will change. Here we will get sigma y minus y bar its square, or sigma small y its square. Again this will change, correlation into standard deviation of x over standard deviation of y. Numerator again will not change here, but denominator will be in terms of y. So we can calculate both regression coefficient with the help of any of these methods to get the value of regression line. Last but not the least, I want to focus some similarities between correlation and regression also. You know, both study relationship. No doubt regression studies functional relations also, but correlation and regression both study relationship. Secondly, both have same sign. And third is, both are independent of change of origin. Independent of change of origin means if you add or subtract any constant from the value of x or y, the value of correlation will not be affected. On the other hand, regression is not independent of change of scale. It is independent of change of origin, but not of scale. If you divide any of the value of x and y with any constant, or you multiply it by any constant, then regression value will change, but correlation value will not change. So these are some basic fundamental key notes which I want to deliver to students of BA BSc second semester. So you should practice these and solve different practical. Then you can contact me through telephonically or through any of the platform of social media, so that you can get your good marks and syllabus covered. Thank you to all.